Unite beyond boundaries. Innovate together. Joe's PANKRATION 2024. No border.
Please go ahead.
Hey, hi everyone. So this is Ankit, and today I'm speaking at John's PANKRATION, and I'll be, talking about demystifying, Kubernetes security using AWS EKS, popularly, which also stands for Elastic Kubernetes Service. So before starting the presentation, here is a brief about me. So I'm currently working as a senior software engineer at Zscaler. I am an AWS certified solution architect, and I also hold specialty certification in the security. I am an avid cloud and cloud security enthusiast. I have been recognized as an AWS community builder as well, and I belong from India. You can scan this QR code for my social media profiles where we can connect, and I'm always open for any queries there. Okay, so let's get started. So here's a brief agenda for today's topic or today's session. So we'll have a very brief introduction to the Elastic Kubernetes service. We'll just revisit the cloud security shared responsibility model, just in case, to understand how we are planning to implement security in this case. We'll talk about what exactly are we trying to secure here in EKS and how do we do it, and then we'll go ahead with the references and questions. Okay, so starting with EKS, what is EKS? So EKS is a service provided by Amazon Cloud, which is a managed Kubernetes service to run Kubernetes in the cloud and on-premise data centers. The session is confined only to EKS using the normal Amazon EC2 worker nodes and security related within. There are other, features or maybe other possibilities and other variations provided by Amazon as well to use the EKS using Fargate like a serverless model, but we'll not be talking about that much. So what EKS does here is EKS, removes the pain point of a user to manage the control plane. The only thing that the user now has to manage is the worker nodes, their application deployment, and that's it. The control plane of Kubernetes is entirely managed by EKS at at a certain cost, and we get the inbuilt Amazon security within. So moving ahead, how will we implement security? Before that, we'll understand what is cloud security. So cloud security basically is the technologies, policies, and controls that we apply to the services on cloud to protect the cloud data, application, and infrastructure from threats. Here we'll be majorly talking about the infrastructure security with EKS and a few pointers around the application security as well, a little bit around that. So cloud security is a shared security model. Why? Because here we don't have the control over the actual hardware. So that part is managed by the service provider, that is AWS here. And what we need to manage here is the security of the services that we have, or maybe the data that get generated, or maybe the identity and access management where we provide access to the cloud resources, the network setup, basically ensuring that your configurations are not open to the internet and only to trusted sources, all those. So that is why this is the shared responsibility model, wherein the service provider, the cloud service provider, takes care of the hardware, global infrastructure, security patches and everything. But apart from that, the security in the cloud, that whatever services we are using, it's us who have to take care of it, right? So moving ahead on the EKS security part now. So what are we looking to secure in EKS? And we'll go through that, right? So first thing is the network. So network is the first step while you deploy your EKS on the cloud. So we have to ensure that the network is secure and best practices are followed while designing the network. Then comes the control plane. Now control plane is provided by AWS, as I mentioned, but then securing it, the access to it, the network security of it, and any other security possibilities with control plane, that is what we need to tackle. Then comes the worker nodes, where the actual compute is hosted and all our applications are deployed. The security of worker nodes is an important aspect. Then comes the identity and access management. So here, what permissions the cluster has, the worker node has, we have to make sure they are precise and to the point, and follow the principle of least privilege to avoid unintended use of permissions via the cluster. Then comes the application pod. So we can apply security policies at pod level. To have security policies at pod level, which can be network related for secure communication, and then isolation with respect to permissions and everything. Then the container images. So the images that we use for our application or maybe the deployments, they should be secure. So that is one area where we need to secure things. Then comes the data. So the data that gets generated, or maybe the customer data that we store through our application, that should be secure. And there should be data in transit as well as data in rest encryption in place. And the logs. So logs is basically to ensure we are able to monitor things and capture the logs so that we can set up our notifications and alarming systems in case of any issue that happens. Right. So these are the areas that we'll be tackling, or maybe we have to tackle when it comes to securing EKS. Now, how do we secure it? So first thing is use of secure configurations. So while you create your Kubernetes service on cloud on AWS, you have given a set of configurations that you need to set. So we need to be very sure while selecting those configuration and ensure they are secure. Right. Second is use of AWS controllers. So I'll give an example. Now, AWS controller for Kubernetes is a recently launched feature or maybe a tool set wherein we can create AWS resources through Kubernetes deployments or maybe Kubernetes templates itself. So how will we leveraging those for implementing security? We'll look forward. Then the security integration. So the Kubernetes or maybe services on cloud can be integrated with resources like the AWS Inspector and Security Hub to get security related information, and that is how we'll be integrating it. And the last point is logging and monitoring. So we already talked about the logging, metrics, logging various set of matrices, and then we'll be showing an example of Grafana wherein you can go through your dashboards and ensure that all your setup is in working condition and there are no issues there. Right. So this is how we'll be briefly trying to secure our EKS. So starting with the secure configuration of network. So the network should be defined as per requirement. There should be a good review to ensure that there are no scaling issues for pod IPs. And then the flow logs for the VPC that you design should be enabled so that the network logs are captured. Ensure that there is subnets are segmented by purpose and private subnets are used for worker nodes so that they are not exposed to internet. Restrictive rules for control plane and worker node security groups should be in place, basically, which means that your endpoints are not public and it is accessible only through a secure source. So here is the configuration settings, how we can configure that. So we can ensure use of private subnet. We can manage the API server endpoint access and ensure that they are only accessible over known IP sources. Moving ahead with the control plane security. So what we can do at the control plane level is ensure that the latest version of Kubernetes is in use so that it is up to date with all security updates and proper AWS support. Bare minimum permissions for EKS cluster IAM role. So we should ensure that only the required permissions are assigned to avoid misuse. Configuration of RBAC to control access to Kubernetes. So network access we already talked about, but RBAC access meaning who can access, which user can access. So we can use the AWS auth config map to basically ensure that only known users or a set of users can access the cluster, and we can also granularize the permissions, saying that only read level options are available for a particular user, or maybe one can be admin and the other can be some custom roles wherein they have access over certain namespaces or maybe other aspects. Then we can use the envelope encryption feature here. So envelope encryption is newly launched, or not fairly, it's a fairly new feature wherein your secrets that are stored in etcd are enveloped an additional layer of encryption using the KMS key. So that is what that also we can do. So it's a basic setting where you just need to specify the KMS key, and once you select it, it ensures that all the things are encrypted. And then ensure logging is enabled. So all the set of logs, control plane level logging, API server, authenticator, scheduler, and all other logs that are getting generated, we should ensure that they are enabled, right? So we talked about the network security practices. We talked about control plane security practices and how we can enable them. We'll move towards the worker nodes. Now, again, same thing, we should use private subnet for worker nodes, minimal access, that is the same point. Use of hardened AMIs with inspector and SSM agent installed. So what does this mean? So hardened AMIs are basically customized with all security best practices followed at the OS level as well by following certain security standards like CIS. So you should make sure that hardened AMIs are used so that known vulnerabilities are already fixed. And then segmentation of nodes using separate node groups so that you have things in different node groups and there is isolation between the same, and you can use stains for it. So this is not linked to security, but it is a good practice to avoid interchangeability or maybe having unnecessary access or maybe to one another port. So you can also use, or maybe for a better view, you can have separate node groups for separate application systems that you have. Now, how to secure EKS? The next point is use of ACK. The ACK is Amazon controller for Kubernetes. So when we talked about this, so this basically is a new feature that is launched through which you can create AWS or manage AWS services using the Kubernetes itself. One use case that we will be talking about here is use of using it for creating IAM roles and policies. So now what happens is, since we have very limited permissions assigned to the worker node, but our application may need some other access to the other AWS services, right? So what we can do here is we can assign access at subsystem level or namespace level using the IAM role and service account integration, and assign that specific permission to that set of pods, or maybe say namespace, or maybe a subsystem basically. So what this does is it sets up different roles for different requirements, so that not the entire cluster or not all the services deployed on the EKS cluster has access to everything. So this is isolating access, which ensures that there is no misuse or maybe no highly admin or highly privileged permissions assigned to the entire cluster, right? So these are the sample templates files. So once you integrate ACK, these are the custom CRD and install the CRDs. You can create a role, and then you can create a policy as well. So you can integrate these with your deployments. So what happens is, if once those deployments are deleted, these also get deleted. So it ensures that there are no unused high privileged roles or maybe lying around in the account as well. So this is a very good practice that we can integrate to help improve the EKS security. Moving ahead with the integrations, the security integrations basically. So one of the security integrations that we'll be talking about is AWS Inspector. So what Inspector does is it automatically discovers workloads and continually scans them for software vulnerabilities and unintended network exposure, right? And once enabled, it will scan the EKS worker node instances and provide the mentioned data. So it will provide you vulnerabilities that are there in your instances, basically vulnerabilities which arise due to different softwares in use, or maybe different packages that you may have installed in the instances. So that those bring in vulnerabilities as well. So we are aware of it, but Inspector will help you detect those, and you can go ahead and fix those vulnerabilities as well. Even Inspector provides some details or maybe resolution steps which you can follow and fix those vulnerabilities. Also, it supports scanning of container images stored in ECR. So Inspector is killing two birds with one arrow here by providing us scanning feature, security scanning feature for both our worker nodes as well as the container images that we plan to use. So this is a brief view of one of the vulnerability that AWS detected. So here, if you see, it provides the CVE related details, which is basically a central database. Provides details about the vulnerability, that what is the vulnerability. So it was through some Python package or maybe the Python package itself. It provides the details of the findings. It provides the account ID. It provides the instance ID as well. I had to blur it out, for security reasons only. So it provides the instance ID. It provides details around the same. And then it also provides the remediation steps. If you see here, it will say that upgrade your installed software packages. So whatever are the remediation steps, it will provide. Right? So this becomes very helpful in a continuous security implementation, wherein this Inspector will keep on regularly scanning your instances. So it scans at launch of the instance, and then it also scans after you apply you install a new package or those stuff. So it is a continual feature, right? The next integration is the Security Hub. Security Hub, again, it provides best practice checks. So whatever best configuration we did, Security Hub will continually scan the configuration and make us ensure or maybe make us aware that some certain security configurations are not properly set. Like for example, here it says enable audit logs. So in the first slide for when we started with the security for EKS, this is what we did. We enabled audit logs as well, right? So if we have not enabled, security hub will detect it and say that, you go to your EKS configuration and enable those. So this will also ensure our end-to-end security with respect to the EKS configurations, right? Then is the logging and monitoring part. So logging monitoring, we already enabled, but how to consume it? So we can consume it through the CloudWatch logs features, wherein we can come here, set up alarms using the alarms feature here, and set up notifications basically for certain events in the cluster. So it can be, high compute usage or maybe some unnecessary scale up happening, and all those stuffs related to that, we can raise different metrics and raise notifications. Similarly, we can consume the data through different application scrape metrics and design dashboards to have a central view of what's happening in the cluster and what is the status of your application, right? So this is how basically, we can implement security best practices and, secure our EKS cluster and the application deployed within. There are many more, features, or maybe there are many more options through which we can enhance the security of cluster, but given the time constraint, this is what we try to cover. I hope this was this session helped you guys a lot, and I would like to thank Josh PANKRATION for this opportunity, and looking forward for many such interactions and sessions going forward. Thank you everyone again. Have a nice day.